This is the Loosely Coupled Show with James Hickey and Derek Comartin. This episode was recorded March 30th, 2020 with our guest, Nate Barbettini. This is part 2 of our conversation with Nate.
Yeah, I mean, what interests me around domain-driven design and kind of what you're doing is just the whole aspect of being a startup. I think definitely in your case, it's more like the early stages, I guess you would say. And for Derek's in it, I guess. You're technically a startup still? I don't know.
I don't even know. Like, where do you cross the line where it's not a startup anymore? I don't
know. One line is when you're like making money.
Yeah.
And the other line is when you're making more money than you're spending.
Yeah.
I guess small business then. Like, yeah. I don't know. Yeah. I think so. Like, these terms are just they throw them around a lot. But
it's extremely fuzzy when people like still call Airbnb a startup, I think sometimes, and they're like a, $100 billion company or something.
Yeah. It's more like a time thing. I've actually seen this before. Like if your company is only X number of years old, you're technically a startup or whatever, but that's kind of silly. But anyways, yeah. So, I mean, I've used DDD in kind of in 2 different settings. One being in an agency where we made software for other companies, and one where I am now, where it's like a SaaS company. They're not a startup, but they're still small. I think we have between 20 employees or something like that.
Yeah, it's pretty
small development team. I know that DDD generally is when you watch like the conference talks and stuff like that, it definitely, even the book, it's applied more to like larger businesses. Sure. Especially when you get into like bounded context and stuff, that seems to be like, we're going to map these and give them dedicated teams. That being said, definitely it happens where, where I am, where you have a domain you're working in or a software product or business that is X number of years old, and it is very complex. Whether you have the people to deal with that or not, the resources number-wise, you're still in a complex domain. And then I think being able to use tools like event storming and I don't want to say context mapping, but those kinds of things. So at least look at like, here's the big picture, and maybe we only want to focus our business on this little piece for now,
right?
And then expand later on. But anyways, that's kind of my initial thoughts, is that for small businesses, you don't hear as much about DDD, how to apply DDD in the small settings. But like all of us here have done it. That's kind of where we're at. So
yeah,
that's kind of what I'm interested in, is like what have you found to maybe be too heavy-handed that might work in a larger setting but doesn't really work. Obviously, like having dedicated teams for that, certain bounded contexts. If you only have a few devs, like you can't really do that. Or even if you're doing cross-functional teams, you're going to have people who are part of multiple teams, right? So then you kind of have to, how do you handle that? But
I definitely would echo what you said, like coming from a situation where we are very small currently. Obviously, we don't want to stay there, but part of what I'm thinking through as, both the CTO making kind of high-level decisions and also the first engineer type of thing, where I'm also currently writing code. I want to think about how to, like, you always have to ride that balance with how do you get stuff done fast today and also like hopefully not hate the code you wrote 6 months from now. Yeah. And to an extent, I think that's always a losing battle. You're almost always going to hate the code that you wrote 6 months from now. If you don't, you haven't learned anything. But that being said, I think there's no way to get that perfect. But there are degrees of, I think, doing it more or less crappily, so that later you could, when you get to the point where you need to hire someone to like work split off, split into separate like functional areas, or you're splitting into a client team and a server team, or you're splitting into like different domain teams or something, that the code isn't just a huge spaghetti mess under the hood and impossible to like factor out into separate services or factor out into different teams and stuff like that. So that thinking through that stuff, and specifically trying to think through that stuff through the lens of seeing those, what I just described, kind of go badly, or not great at previous things that I had worked on, was what led me to exploring DDD and some of the concepts of that, everything that goes into that architectural style, if you can call it that. I totally echo what you said, where it's actually I found it a little bit hard to parse a lot of the good DDD advice that's out there, because most of it is written for like projects that are so big that they're like collapsing under their own weight type of thing, or like you have this 20-year-old thing and you're trying to refactor this ancient monolith, and how do you do that?
Mhm.
Even Eric Evans' book I think he does a good job of really laying out the basics, but even that is kind of tinged with that a little bit, where a decent portion of the book is talking about how to map, like how to explore and decompose or think about like an existing complicated domain. And less of it, I felt at least, less of it was talking about how do you like explore a domain for the first time if you aren't familiar with it yourself. I don't know, that could be me bringing my own bias to it as well, but it's certainly difficult. I feel like it's almost the opposite problem that I find with a lot of coding tutorials, get started with whatever it is, Node or GraphQL or TypeScript or whatever cool stuff is going on right now. It's really easy to find that like 101 content for programming languages and stuff. It can be sometimes very difficult to find the like 201 level content, where yes, I've done the hello world. Yes, I've thrown up a Node server that can respond with like 200 OK. Yes, I've put together a GraphQL API that can respond with one thing. Like, but what does it actually look like to get this to the next step where it's actually useful and production ready and has all these other concerns that come along with like doing something big or just doing something like production ready. It's harder to find that higher level content for languages and frameworks and stuff.
Yeah.
It seems harder to find the introductory content actually for something like DDD for me, because a lot of it is written of like from the perspective of like, okay, you have this massive monolith and you're the guy who has to come in and refactor it. How do you do that? Well, I'm not there yet. So how do I tell me how to prevent writing that big ball of mud in the first place?
Yeah.
Which is what attracted me to it. I think ultimately the reason I was really interested in it was to have a framework, more like a framework for thinking, being able to think through and even just put names to things that I was trying to think through as I was thinking about architectural concerns.
Mm-hmm. Yeah, there's probably two big things that I think are super important with DDD, like regardless of whether you're in like a small setting or a huge organization.
This is good because this is going into my notes for my future blog post on like DDD in simple English or whatever I'm going to call it.
Nice. Yeah, like I was on Steve Smith's weekly dev tips once, I don't know, months ago or whatever, and gave like a little thing, whatever, 8-minute thing about boundaries. I think that's really the big thing is like as soon as you can put a boundary around something, it really doesn't matter how messy it is in the inside, as long as there's like a nice contract or a nice like API. Now I say that it doesn't matter. Yeah, it does matter. But in kind of the grand scheme of things, one of the benefits or one of the things that DDD emphasizes is you can put boundaries around different, domains or whatever. We'll just call them things.
Or business objects.
Yeah. And you can decide which ones are the most important and allocate more resources or more time or, more investing to make sure it's higher quality than the others. And I mean, that's probably the most important thing for me. But then I think the other thing is just this idea of being really explicit and not generic. So for example, like you take, let's say like life insurance. There's actually a project I worked on before that they were doing life insurance, and I helped them build this web platform for people to apply for life insurance. One of the things they wanted to do after this was done, they're like, oh, we should do home insurance and we should do vehicle insurance. I think typically if you were to hear all of those requirements up front, most developers would want to build, they're like, it's all insurance. So let's build something really generic and that's configurable, and you know what I mean?
Where's my abstract insurance factory of tea?
Exactly. And it's like with DDD, it's like, no, like these are separate businesses. It actually might be more beneficial to like totally isolate them. Like vehicle insurance and life insurance will be done totally separately. They will not share the same concepts or ideas. And then that's where you get into this idea of context, which Derek has done a talk called Context is King, which is like an insurance policy in life insurance and vehicle insurance. Yeah, it's a policy, but they're probably totally different kinds of things. And I think it's like being really explicit. Like this is a life insurance policy. It's not associated to vehicle insurance at all, even though the names are the same. We're just going to totally separate them, be explicit. I think that's where a lot of like really weird, messed up code ends up coming from, is when you just try to combine all these different concepts into like one. I don't know, Derek, what do you think? Because I mean, you've done like the talk on Context is King, and you have a lot of experience with that in the business you're working at right now, I know.
Yeah, I have a few different examples, and I'm going to steal your policy one, because that's probably a pretty good example I can use. I just got to elaborate on it more. But the example I always use, or the primary one I always use, because I think everybody can get it regardless of understanding the domain. So in distribution, so like in a warehouse, and having kind of a big system, kind of an ERP style system where you're dealing with everything, right? You're dealing with the warehouse, you're dealing with purchasing and sales. My example all the time to equate this is I always say a product isn't a product, meaning that the product in the warehouse, yes, it's a product, and you could think of, oh, we just have this massive system and there's this one concept of a product. That's not really what it is, because the way that somebody in the warehouse thinks about a product is very different than the way that somebody in sales thinks about a product, or purchasing thinks about a product, or in accounting thinks about the same product. How, like, kind of what their job entails and what they do around that thing is different. So a product's not a product, meaning the easiest way to think about this is if I'm talking to somebody in sales about a product and we use the word price, they're talking about the sale price. They're talking about the price. I mean, they're customer centric, so they're talking about the sale price. If I'm talking to somebody in purchasing, we say the word price. We're not talking about the sale price. We're talking about the purchase price from the vendor or from the manufacturer, right? So a product and price, we could be using these words interchangeably, but when I'm talking to different people, they mean very different things. And that usually is my immediate sign that no, there's a boundary here. So it's usually just like you said with a policy. Yeah, it's just the word policy, but they mean very different things to different people.
Yeah, I think it's easy to like, especially when you've like already dissected the differences, but then when you're actually like in a new domain, a new domain, or a domain you are not very familiar with, I think that's where it's kind of like what Nate said. There's a lot of the like 101, but then they're like how. Yeah, I mean it's hard, right? It's like if you're gonna write a book or like a tutorial or something about how to do service boundaries and all that stuff. It's like you're not going to want to spend like 3 days giving this content just to discover, okay, yes, we're going to split life insurance from vehicle insurance, right? Like, and it's like, well, the reality is sometimes like that's the way it is. Like you end up spending like days and weeks where you finally get to the point where you're like, actually, we're not going to split it this way. We're going to split it a different way. And then you kind of get this like epiphany. It's like, oh, it's like all these other pieces that you had trouble with start falling into place, which is really cool when that happens. It's like really exciting, but yeah, it's hard. I mean, that's really hard. I like, I mean, there's so many different ways to do it. I like Udi DeHaan's approach. It's kind of like the SOA. I know there's a term for it. I forget what it is, but it's a very like data field centric way of doing it, where you basically say like at this stage I need these pieces of data, and then at this stage of, I think it's called like an entity lifecycle or something like that. I don't remember.
That sounds vaguely familiar, yeah.
Yeah, but it's basically like you map out your different pieces and you like explicitly list what pieces of data you need. And it's kind of like the price thing that you're talking about, Derek. It's like in one case you'll see price here, and then you'll see price kind of in another place, and you'll realize like, oh, maybe
red flag. It's not the same thing. It's like a bunch of tricks to talk people out of the don't repeat yourself muscle that everyone has trained up so strongly when you're writing code.
Yeah.
Here's kind of a 201 question maybe. So I think it's pretty obvious to anyone, like the explanation you just gave, Derek, or both examples really. It's pretty obvious that like, yeah, obviously a product means something very different to sales than it does to the warehouse, than it does to shipping. So you could have different business objects that represent like a sales product, a warehouse product, a shipping product that's in a shipping container or whatever. That all makes sense. What happens, like, how do you think about it when the business says, yeah, you're right, like, it's awesome that we can reason about these things in each different stage or each different context, but I want to track a product all the way from acquisition to sale to shipping. Like, I want to track it all the way through. How do you think about those types of relationships between, like, either a relationship like between maybe it's the same thing, but it's through different contexts?
Want me to go first?
Fire away.
So I like when I hear that, I think about kind of use like Amazon as the example.
Oh yeah.
And usually what we think of is the order, right? So you fill out your form and you have your cart and you say, yeah, I want to check out, and put all my information in, and then
I just click that one click buy, ship it to me, prime it to me immediately button. But
yeah,
yes.
yeah, but not doing that, but like the typical process, you would go through the whole checkout, and then at the end, the way we like the typical programming scenario is at the end we finally generate like the order ID. When everything's finalized and everything's hunky-dory and we're ready to maybe pass that off to shipping or whatever, now we're actually going to like send that to the database and get an ID back. Whereas generally when you start doing more like service oriented stuff or like GDD, usually what you do is the opposite. You have, as soon as you start that whole process, you generate the ID for the order, and so you have like an empty order. And now basically as you progress through the stages, you basically you're going to start like emitting events. So you'd say like order created, and you might have like the, I guess, main order context or whatever that'll say, okay, here's, or actually that would be the context. So you'd say here, this order has been created, and then you might have like the payments piece, shipping, there's probably other ones, but then they might get notified like, okay, here's a new order. I'm going to create an order that's kind of a placeholder now. And then you do your payment, and the payment, you know what I mean? Like, so you have an actual order that's created in all these cases. So it's kind of like a long living process. I think that's the difference. Is it's hard to, we're so used to thinking that like if I have this database table or row, I guess database row or just this entity or whatever, like I need to give it all of the information before I can create it. And that's more of like this transactional kind of thing where the whole transaction has to be everything at once. Whereas now we're talking about more like sagas or like distributed, more kind of like these distributed transactions where depending on where you are in that process, yeah, you're going to have incomplete data, right? If I'm at the stage of actually I've paid for my product, but I haven't finalized it. I don't know, right? Like I've paid for it, but it's for whatever reason it's not actually ready for shipping.
Right. Card came back invalid, so I need to try again or something.
Yeah, exactly. There's like it is in an inconsistent state in a sense. Like I say inconsistent, maybe incomplete is a better way to put it.
Yeah.
So like shipping
it's
knows
a valid but incomplete state.
Yeah, so that's kind of I like that. It's kind of like recognizing that these intermediary states are like legit business scenarios, right? It's legit that your card comes back declined. Shipping knows there's an order, so maybe there's other things they can do to get ready before they actually like have it finalized. Maybe they can pre-pack all that stuff just to be like efficient, but they're not actually going to ship it and create like a shipping ID before the payment's gone through. So yeah, it's kind of like pre-generating that and the order in this case, but it's like you pre-generate the ID, all the contexts that interact with that kind of start up their kind of starting state. So and I guess you treat them all like little mini state machines and tell them what has happened in your system.
So Derek, in the case of what you were talking about, like a product is not a product, based on what James is saying, it sounds to me like the product is not a product, but the product ID maybe is the thing that is like that's the true unique identifier globally through the whole system, and that's the thing that you could like if you need to query on it or the business suddenly asks like, okay, but how many times did we buy it at this price, but then it was sold at a different price? Like, help us do this analysis. That's the thing that you would actually use that would be the same through those different representations in different contexts.
Yeah, so I should have clarified that at the beginning, which is, you are going to have something unique that's going to identify that particular product across all contexts, like different services, right? Like you're going to have a SKU, for example. That's going to be the thing that you're going to identify that same mug or whatever across sales, purchasing, warehouse, wherever the case may be. And the other thing I want to point out too is that like when we were talking about just like price and kind of where data points live and kind of where they're owned, there's nothing wrong with, for example, the sale price to live somewhere else for kind of cash read purposes, right? Like you don't need to have, it's just about ownership of where the point of truth is for any specific piece of data or behavior. But that doesn't mean it can't live somewhere else, right? Like if you need to have the product sale price in purchasing because you want purchasing to be able to know what the gross margin is, well, sure. Right? Like it's not, or vice versa. Maybe you want to know in sales what the purchase price is because you want to know gross margin there. Like it's just that where the ownership of that data is needs to reside in one place ultimately.
To say that a different way, I totally get what you're saying. You're saying that having a single source of truth or a single, in DDD terms, a single like root that owns the definitive version of that data doesn't mean that that's the only place you can go get it, or it doesn't mean that that's like a single point of failure. And if the purchasing service is down, you have no idea what anything costs. You're just saying that like if when you're thinking about things like eventual consistency or where the true like authoritative version of that data is, it's only in one place, even if it might be copied and cloned to a bunch of other places.
Correct. Yep.
Yeah, I think you get into more nuanced scenarios too, right? Like it's possible that, let's say, your sales, in this case, your sales price, that would be more, where would that be in your like marketing? I don't know, like your purchasing context. Let's just say it's in your purchasing context. So your sales price, which is what your users buy it at. Maybe another context or another service needs that information. In some scenarios, it might, maybe if it's not such a like, if you're not going to need that information tons, so you just need it for like this one specific scenario, and that actually doesn't happen very much. Maybe you would expose that as a REST call, a REST API, and just say, I need this piece of information. I'll make that call. But then definitely, if that's a piece of information that you need a lot, then probably makes more sense to just put it right in that service. Yeah, you'll have that data duplicated in the payments and then maybe somewhere else, but it effectively acts like a local cache, right? So your performance is a lot higher. You don't have to make those cross-boundary REST calls.
Right.
But I know a lot of people like frown upon the REST stuff. I've seen the two extremes. Like one is like every service is a REST API, and it's like, no, that's not going to work well. On the other side,
every
it's
service should have an API, an explicit API. That doesn't mean that it has to be REST.
Yeah. And then the other spectrum, it's like everything has to be events and messaging. Well, no, not necessarily. I mean, it's
kind of like, it's hard. It's complex.
Yeah. Sometimes there's not a right answer. It's, well, what works best for us right now. And those are kind of the harder scenarios, I think, where you have multiple options that actually look good. But
I think something you mentioned earlier, James, is one of the other big draws, was one of the big draws to DDD for me, because I wasn't, when I kind of graduated into the role or was drafted into the role of architect, I wasn't coming at it from like, I'm a big DDD expert already, or I have like all this knowledge myself. I was also learning it as I went. But one of the things that really attracted me to it is something you said earlier, which is about being really explicit about the API, the explicit API of like business domain objects.
Yeah.
Because one of the things that I, as a younger programmer, was really frustrated by in previous stuff I'd worked on was, I think I mentioned it last time we talked, the situation where like really boiled down to two things. One was the idea of like the service layer being this big spaghetti code. It's like everything from like the API controller down was just a massive spaghetti code where like 60% of the business logic was in the API controller itself, like right at the controller layer. And then the rest of it was in like a bunch of different services that were like kind of loosely coupled, but they also were doing way too much stuff themselves. So it's easy to add functionality in that situation, but changing functionality is really hard, because if the business comes back and says like, okay, now we want to make it so like you can't order something unless you already have like your account approved or something like that, then you go to like every single place where you had been making that decision or whatever. And if you're lucky, it's like in a service somewhere, but if you're unlucky, it's like scattered across 13 different controllers, because you have like one for the web and one for the mobile API and one it's all over the place. So having the idea that coming from my previous background, which was like in like SDK design and library design and stuff, I had to think really hard about what the published external API was for some, like the contract was for some SDK. Here are the things you can do. Here are the explicit inputs you can do. Here's like what makes sense, and trying to design API interfaces at the code level that helped make it easy to do the right things and hard to do the wrong things. But then I didn't see that at all in the application code that I used to write. So this idea that actually the nice thing to do is to package up not just the data, but also the behavior of some domain object, like a purchase order or a invoice or a policy or whatever, packaging that up, being really specific and explicit about what it is. It's not just a policy, it's a home insurance policy, or maybe a certain type of home insurance policy or whatever. Having that boundary, and then being really explicit about the like actions that can happen, the behaviors that happen on that object, and ideally having that code that does those actions even inside the object as well. Because the second thing I realized after I learned more about it, the second thing I realized I was struggling with without even knowing it, was what Martin Fowler calls the anemic domain model, where you have these like DTOs or domain objects that are like a user, a purchase, an invoice, but they're really just like these property bags of data. So at least you're like, you have some kind of like a contract or a type, a schema around the data maybe coming out of your database. But then after that, anything that acts on that data or has behavior associated with that business object is like shoved in a service somewhere, or even worse, it's just in a controller that's somewhere that is dealing with that particular put on the API or something. I didn't even know that was an anti-pattern until I read about it, and I was like, holy crap, I'm doing this all the time. So those, like, just being, probably if I didn't learn like anything else about DDD, and there's a lot of other good stuff in there, but if I didn't learn anything else, that was probably the most helpful thing, was to change my thinking about having rich business objects that included behavior, and not being not anemic in how they're designed. It kind of like answered a question that I had open in my head for a long time, of like, where do you put logic that acts, that's supposed to represent behavior of that business object? The obvious answer is on the business object itself, but that wasn't the pattern that I had learned when I was a younger programmer. It was the accepted pattern in like NT architecture was like, oh, it should be in the service layer, or you have like a business domain layer or something. I think now I have like the second order question, the 201 question of like, okay, now I have situations where there's business logic, but it's business logic that acts on multiple domain objects. So now I'm not sure where to put that, because it's not truly part of one or the other aggregate. It's like kind of seems to affect both of them. So now I'm not sure what to do with those. Maybe I haven't read far enough in the DDD book yet.
I think Derek hasn't said anything yet. I think there's maybe
No, it's that's like, I think probably the most common question, I think.
Good to know, I guess.
When people start talking about aggregates and aggregate roots, is the examples of either uniqueness, or that's a common one, or when something is across an aggregate root, meaning it's across a boundary. And it usually comes down to, one, just really understanding the example a little bit more, like very, not even like the actual use case specifically. And I think there's usually, a couple outcomes, which is the boundary's wrong. The boundary's wrong because, like, an aggregate root to me really is just a consistency boundary.
Right.
It's controlling invariance. Do you need them to be consistent? I guess is the question of whatever the behavior is.
It's a surprisingly hard question to answer sometimes.
Yeah.
Yeah. And
because
then
sometimes, like what you're saying, is sometimes it's legit. Maybe you have two aggregates, whatever you want to call them, and you act on one, and it actually emits a domain event, which triggers the other one to do something.
Mm-hmm.
So, like, throughout this whole long-lived, call it a transaction, it's kind of like a distributed transaction, depending on, well, essentially.
It's things that need to happen in the system, yeah.
Yeah, so it's like eventual consistency, right? But within that whole flow from start to finish, you're still enforcing that. In that case, if your boundaries are correct, sometimes that happens. But like Derek said, sometimes maybe you do need, like, this needs to be, it's Without an example, I guess it's a little harder. But
Yeah.
anyways, you're going to keep going.
No, I'm just saying, yeah, like it's the example, and it's either the boundaries are wrong or the risk of things being inconsistent and the likelihood of them being inconsistent, and how do you deal with it. I think there's this assumption a lot of times that that developers have over these certain situations where the simple answer is somebody running a report once a week that shows them the 0.1% of issues that occurred from this. Like, it doesn't need to be perfect all the time, I think, is another
I know what you're talking about. You're talking about where it's like, well, technically the system is eventually consistent, so like if the user clicked at the exact same time another user clicked, they weren't going to see the newest data, or like something could get lost. But it's like I think it's very useful to think about it, because if you're not thinking about it, then you're going to run into guaranteed to run into problems.
Yeah,
but
I don't know.
Because
I don't know if this is a good example. I've been in my head as I'm talking, I'm trying to think of a good example that I have. And this isn't maybe exactly it, but maybe it kind of gets a point across, is when we go back to the warehouse example, I always use the idea of whether sales needs to know, like somebody selling products, right? Do you need to know the quantity on hand of a product? And again, that would kind of be like, well, products are being purchased, how do you keep that up to date, etc. And as a developer, you probably think, oh yeah, we need to know. If you think of anything where you have like a finite number of things, right? And you're like, well, yes, we need to know the exact quantity on hand, because we don't
quantity
want to
minus.
Yeah, we don't want to oversell something. Maybe that's the rule that you just assume is the case. And in a lot of circumstances, that's not really the case. And these things have existed, or ways around these, or business processes exist because before things were digital,
right?
And how to handle something like overselling. Yep. And again, without asking the questions and just making assumptions, it's, again, a lot of these things already exist. So with overselling, at least in the cases that I've been in multiple different kind of distribution environments, that's not a sales problem. It's a purchasing problem. If you oversell something, they just need to get more of them. And then at the same time, the idea of a quantity on hand is this made up thing, because sales doesn't even use that, and they have different ways of dealing with quantity on hand. And they don't call it that. They actually have business terms for this. So where I was going with this whole thing is that if, like, assumptions in describing these situations, how you've modeled it to the business and what the implications are, because they may just say, oh, actually, that's not even a problem at all. And if we do run into this, like, how would this be done manually if this, like, to communicate this information? And likely that domain already has processes and how they deal with it. Very likely. That's a scenario I've been in most times, is assume one thing and like, oh, this is a mess. This is a transactional nightmare. It's like, oh no, that's not even a problem at all.
I think that also gets to the heart of why it's so important to ask those questions and understand what is and isn't important in the domain. Because in that example, I think Udi Dahan also had a really famous article about exactly what you're talking about. Like, look, sometimes we're really afraid of eventual consistency. Sometimes it's like not a problem at all, or it's not the problem you think it is. But there are also situations where, like, yes, it is extremely important to have like an atomic decreasing count that is guaranteed to be consistent. If you're building, like Robinhood's stock trading platform, like there is no scenario where you want the user to be able to like buy a share of something when they don't actually have that money in their account, right? Like that has to be consistent. Because if it isn't, then that's like you're like losing money out of your pocket because you're having to cover your software making a mistake or something. But those are two very different domains, and that drives a very different conversation about like whether consistency is extremely important or moderately important or like not a big deal at all.
Yeah, I think one way to like explore that too is if you take your, let's say you have two different, I don't know, let's just say you have one aggregate that you've made. The typical, like, you have your order in line items or whatever, right? Shopping cart, or I don't know, order in line items or whatever, some kind of like hierarchy of like children.
Right.
And then if you say, okay, yeah, there's certain invariants or certain business rules that apply to like the main entity order, whatever it may be. Excuse me. And then you might have rules that apply to the children explicitly. Anyways, basically, if you say, well, what if we make the children, or maybe we take like a sub piece of this whole root, the whole aggregate, and we take a sub piece of that, and we say, what happens if we actually make this its own aggregate, and then we apply the action to this kind of new, lesser, new aggregate with less in it, and then with eventual consistency, you emit an event, and that causes this new aggregate to do what it needs to do. And so you have kind of these smaller chunks where there's kind of like, you kind of have this like event thing. It's like the eventually consistent thing where each one's doing one little simple thing and then emitting an event, and the next one is doing what it needs to do. But then asking the question, if we split this off, and it means that this new piece is actually there's gonna be a little lag between when this updates this, like what are the business implications of that? And obviously you need to ask your domain experts and be like, if a user does this action, is it okay if this scenario plays out where this thing is changed, this thing hasn't been changed yet? And like I think
they refresh and the quantity hasn't fully updated yet or something.
Yeah, whatever. Yeah. So I think, yeah, that's one technique that I like to use, is just because we always kind of it's hard to think, especially if you've already like come up with the model of what your aggregate's going to look like, and even if it's coded already. I think it's a good exercise to start playing around with that and kind of just think, what if we moved things out or moved things in, kind of like what Derek said, maybe you have two aggregates and they actually should be one boundary, depending on the use case. Maybe that's actually more appropriate. But then the opposite could happen, where actually your boundary is too big and you can bring that in a bit more and have multiple pieces. Then I think you start getting into like the reactive patterns, I guess. It's more where you have smaller aggregates that are emitting events asynchronously. I guess you could still do this synchronously if you're doing it all in memory too. Sure. You could just kind of do it in memory and call the next aggregate, make the this cascading event thing. But then that kind of releases these new questions for the business experts, which I've seen in that case can actually, in rare cases, but it can happen where you actually lay it out a different way, and you kind of discover this new approach to even like do the business process itself.
There's one other question that I've been working through kind of from an architectural frame of mind, which is there's a certain kind of thread of it or brand of advice that I've gotten more than once, which is like, especially when you're early in something, like rely on the database as much as possible, or like put as much as you can into the database instead of into application code. And that's something that I've always struggled with a little bit, because to me, like I struggle with how much to rely on the database, in the sense that, like, to me, application code feels much easier to test, much easier to like have change control over and stuff like that. Versus, like, for I guess a concrete example of this would be like relying on, if you're using Postgres, for example. Postgres has specific extensions that let you model like more complex data structures in the database itself, instead of having those as joins and then doing that in application code or whatever. Or even just joining across tables, I guess, is an example of something you do in the database rather than doing it in application code. but there's a tension, it seems like to me, between this idea of doing as much as possible in the database because that's like fast and it is really portable if you decide to throw away the application layer and rebuild it in some other framework, or you change the way the team is structured or whatever, the database is still there. Kind of like the database is the thing that's long lived for any company. It's where like most of the value act truly is. So I was it was difficult for me to think through that because my immediate reaction is like, well, I'm coming from like really liking tests and really wanting to test the objects I write. Like all of the tests about object behavior and stuff feel like they belong in application code. But I don't know, how do you guys think about that?
You want to go first?
I've never heard. I've never heard that recommendation. Really, like to push as much you can to the database.
I've seen it.
I've seen it in practice. I mean.
I've seen it in practice, yeah. But like, I mean, if it was a recommendation, if we're referring to like, I don't know, like 10 years ago plus of stored procedure out the wazoo that has all this logic in it, I kind of think that has gone by the wayside.
I think that's very similar to like when like ASP web forms first came out. Like when it came out, it was very revolutionary, right? Now we look Now we look back and it's like, no, but when it came out, this was like pre-Ajax, right? So it was like, man, well, I was going to say you can do it from the UI. Actually, they scrapped that pretty early on, but I mean, yeah, like
you could do that. It was awful, but you could do it.
Yeah.
And even like to your point, you have to understanding the context of the times. That was even good at the time because what it was replacing was so bad.
Yeah. So I mean, people watching this are like, we have like Ajax and we have single page application frameworks, React and all this stuff. Yeah. And it's like, no, we literally didn't even have jQuery. We didn't have Ajax. It was like just post facts basically. Like you just post and get. But anyways,
that was so much better than writing a classic ASP where the code and the page was one file and it was all the same thing.
Direct queries to your database from your
PHP
page.
style.
Yeah, so I think that style definitely was tied together with like the database centric approach. But anyways, what I was going to say, I forgot and then I remembered, is that was a very like rapid application development centric thing. So like a RAD kind of thing. That was kind of what they're promoting, is you can rapidly prototype, or you can rapidly develop these websites. Because the UI is so easy to tie together with your database tables, essentially, right? You can just kind of map everything, and
no way that could go wrong.
No, just bind your UI to your database, basically, and it's so fast, which is true. It's very fast, but then you get like, for small applications, that's fine, right? It's like, it's always trade-offs. If you're building a very small application, that might be fine, but as soon as it's like starts growing, it just gets out of hand. Yeah, like I think that applies, is this whole database centric thing for small applications. Maybe that works. And maybe for very specific scenarios where you actually do need your logic to be very close to your data in your database, because maybe you're doing like some heavy data processing. Sure. That makes sense. Sure, do a stored procedure. But otherwise, I mean, my opinion is, like you said, do as much as you can in the application code. You can test it. You can model. You can be more expressive in how you model things, because that's what a programming language is for. That's not what databases are for. They're for storing data. Yeah, and then you look at like kind of the trends with domain-driven design and microservices, and even going back to service-oriented architecture. Which is kind of all the spectrum of the same thing, I guess, in a way. But typically, as you go on, the recommendation is to put to make sure each service has, or each context has its own database.
Right. True.
And it's like, yeah, that practically, maybe that's not practical for smaller companies, and you might want to maybe segment by schemas and whatever. But, that is trying to avoid these cross schema joins and cross schema, blah, blah, whatever. And that, I think once you start doing that, it's easy. Yeah, it's easy, and it's maybe more performant right now. But once your system grows and the business is successful, and now they want to add new features and maybe change how things are done, now you have to untangle that mess, right? And that is a huge cost, huge payment that you have to pay in the future if you're not aware of that.
So maybe final DDD question for you guys. When you think about when you think about building, say, you're approaching a new domain, and so you're exploring the domain, you're asking questions, you're understanding how the domain relates to itself and all this good stuff. You're obviously thinking about, eventually you're getting to the point where you're designing code objects and writing code. Where does that come, before or after you design database tables and database constraints and columns and all that stuff?
Yeah,
or does it depend?
I mean, I would say ideally the database piece is probably one of the last things you want to do, but sometimes you can't, sometimes that isn't so practical. I think it depends is probably the better answer. But
you would say that because I think what you're saying there is that the way the data is stored ranges between a trivial implementation detail and a sort of significant implementation detail depending on the situation, but it is still an implementation detail of how your objects work and how the domain works.
Yeah, and then I think I've seen people say this too, right? And start with your database, start with your tables.
Sure.
But then I think if you do that, even if you're very cognizant of the fact that your application code probably shouldn't match your database tables necessarily, that's going to happen anyways. I think if you start with the database, it's going to drive what your code looks like. So I think if you can defer that as far off as possible. But I mean, you do have to consider data. You do have to start doing data modeling and be well, here's this thing that a customer can do. What fields what fields can the customer supply to us? And now we have to think about going back to the way Udi Dahan talks about it. We need to look at all these fields and see which ones should be grouped together. So if these three are always part of the same business rules, or I know if I change this, it affects these two, that means there's a causal relation between them. Then those probably belong together, but they don't affect these other three, so I'll put these somewhere else. But you're not talking about database tables, you're talking about service. What data does a service own?
Right.
You could store that as a document in a document DB. You could event source that. You could put it in a relational database. So I think that's an implementation detail, because maybe you want to do event sourcing. Maybe that's important for that context or that service. But maybe you do have data that you need to query in complex ways. So maybe a relational would work out better. So yeah, I think I would make that distinction between just because you're looking at pieces of data doesn't necessarily mean that it's all a table or whatever.
Right. Yeah.
And it's hard. It's hard to do that. I think to make the distinction between those two things. So, how about you, Derek?
No, I think you said that pretty. Yeah, I think you got that. I'm on the same page with that. Yeah, I think I always say, I mean, behavior and data go hand in hand, so I don't think that one comes before the other. I think they're mutually happening at the same time to figure out what the behaviors are, what data that affects, like you said, what the business rules are, what fits where. I think they just go hand in hand. I don't think there's like, hey, I don't know how you would do a schema first without really knowing what it is that you're recording and how you should record it. So,
I've seen it done. It's just it never works out very well.
Yeah, I mean, it happens, but
I know what you mean.
Yeah, I just feel like it's more about just a better understanding before you start all of a sudden jumping into code, I guess would be more of my thought.
Yeah, that is a good thing. It's really easy to jump into code too early, for sure. I'm like guilty of that all the time, because it's easy to feel productive when you're like, oh, I can just like bang out some code. Yeah. But I've noticed that there's also like, it's also kind of a quick, I don't know, knee-jerk reaction maybe as well. Like sometimes when you're exploring a new domain, or you're like, okay, I'm going to build this thing that does X. Sometimes it's also a knee-jerk reaction to like jump in and be like, okay, what are the tables going to be? Well, I need a user, and I need an order, and I need an order row. So like those are obviously going to be tables, and then just go down the rabbit hole of like designing all the relational links between those, or how you'll do it in a document DB or whatever, before you even really model what the behavior of the system is, I guess.
Yeah, I like the response you gave in our first video where you explained why you were using event sourcing for the company you're working for, and I think that's kind of what we're talking about, right? Is like if you know you have those requirements where you need to audit everything you're doing, then that affects how you're going to implement that, right? That's kind of should come before you design your tables. Like you said, what if you would have designed all your tables and now you're like, okay, every single table is going to have a corresponding like history log table, right? And it's like that's probably an indication that there might have been a better way to do that, right? So
that actually is probably maybe a good example of what at the top of the question. I think that would be an example of that style of advice where it's like, put as much as you can, let the database carry as much of that as possible. So you could say like, well, we do have a history table for every table, and the way it works is that there's a trigger that's customized for every table that automatically inserts a history row every time the main database table changes, or we have a trigger that like emits to a log every time or whatever. It is possible to do all those things at the database level. It just seems like, and I've done some of that in my application as well. Like there's some really cool stuff that Postgres can do that makes querying our data a lot faster, and it's really nice. But when those triggers need to change or evolve, it's a more difficult story than like, throw a new unit test around this new behavior and go. Because at the minimum, it's like it's an integration test at least, because you're really testing stuff that goes like all the way down to the database level and making sure that it behaves the new way that you expect it to, etc.
Yeah, and I like CQRS because of that, where just add a new projection, or I mean, if you need to change an existing projection, then you just do that, and away you go.
Yeah, it's interesting. CQRS is not universally loved. Even like Martin Fowler on his big wiki says like, you probably shouldn't use CQRS. Like it's really hard, or he has a reason why. He's like, it's like not needed in most cases or something is what he says. And I've seen like on Reddit discussions and other places, a lot of people kind of dislike it, but my best guess is like maybe that's because they've used it in a scenario where maybe it wasn't needed or something. But it seems to me like it has some really nice benefits to, if you have an application where like either reads or writes are like much more common than the other, forking that path so that you can like do different things on one side than the other seems really nice.
Yeah, I think it's just there's trade-offs.
There absolutely are, yeah.
As long as you're aware. I mean, yeah, it's like no matter what you do, it's going to be hard.
Yes.
Like we said, if you do like a RAD approach where you're just going to like hack everything at the beginning, it's going to be much harder later for you, or you can put some more effort up front and make things easier in the future.
The really difficult trade-off there is when you're in a situation where you're like a very small company, or you're doing something where you have a limited amount of runway. For example, you have maybe a year or something to get something off the ground, but if it's not selling and making money by the end of that time, then you hit the end of the road. Then that trade-off definitely becomes more difficult, because then you might do it really nice and super well and really well designed, but the company ultimately dies, or you might do it really crappily and the company survives, but then phase 2 is really hard because you have to hire like many people to clean up the mess you made. I don't know. There's no perfect answer there for sure. It's tough.
I think in that case, it's like, what if you can just like make a list of like what possible things we could do. Like, here's the list of, we could use event sourcing, or we could do this, or we could do that, and let's pick 3. You know what I mean? Like, because obviously if you implement this whole list, it's going to be a lot of time and extra effort.
Yeah.
Whatever, pick a number. What 3 are going to give us the biggest bang for our buck and make the biggest impact, and all the rest, for now, we just don't have the resources to do.
Yeah.
So, and again, you can apply that like to
that
different
goes all the way down
contexts.
To like the feature level too.
Yeah, exactly. So
you have 100 things that need to happen, and you can pick 3.
Yeah.
Which 97 things are you not going to be able to do right now?
Yeah. Yeah, that's hard. And I guess that's kind of the role of the CTO, is like, you've got to decide what those things are going to be.
Definitely.